we're going to look at the half angle and power reduction formulas. You're going to learn pretty quickly that both of these come from the cosine of a double angle, so they're pretty easy to derive. And if you end up in a position where you have to memorize them, they're also pretty easy to memorize. Before we get to the lecture, though, I want to go ahead and start with this reference sheet that I found. There's lots of different reference sheets that you can find online. This is the one that I'm working off of. However, we're not going to be using all of these. So, okay, I've got my pen here. So as we're working through the first couple of rows for sure, so you see a lot of them. The half angle, we're going to look at that today. The double angle identities, we're also going to be revisiting those today. We are going to be doing the law of cosines, but that's going to be a little bit later. So we're going to see the law of cosines a little bit later. The law of sines as well. We'll see that one a little bit later. The ones that we just don't have time to cover in class are the product to sum. So you can put a line through that one. The sum to product. We are doing the sum and difference, the cofunction. We are not looking at the law of tangents. Now, if you don't want to cross these out, that's fine. But if you want to maybe just put a star next to them so that you know when you are solving an equation or verifying an identity, none from those groups are going to pop up. We're also going to see the power reduction formulas today, which are not on this list. So I recommend that you add them to this reference page so that you have all of the identities and formulas all in a single spot. Let's go ahead and start with the lecture. To get to both the power reduction and half angle identities, we're going to start with the cosine of a double angle. And I've got the cosine of a double angle written here. Let's go ahead and grab a pen. There we go. Okay, so I've got the cosine of the double angle written right here. When we're solving for part A, the cosine squared, I want to rewrite this all in terms of cosine squared. When we get to part B for sine squared, I'm going to write the cosine of a double angle all in terms of sine squared. And we're going to do that with the Pythagorean identity. So cosine squared alpha plus sine squared alpha is equal to 1. So as I start in deriving the cosine squared of alpha, I want to rewrite the double angle formula all in terms of cosine squared. So I've got cosine of 2 alpha is equal to cosine squared alpha. We're going to replace sine squared, so minus sine squared, with 1 minus cosine squared. I can distribute that negative sign, so cosine 2 alpha is equal to cosine squared alpha minus 1 plus cosine squared alpha. So I still have that cosine 2 alpha. I have 2 of the cosine alphas minus 1. I've got to add a 1 to both sides. So I've got 1 plus cosine 2 alpha. And then the last thing that I've got to do is to divide both sides by 2. That's going to cancel. And that leaves me with my formula. I can rewrite cosine squared as, let me put it up here, 1 plus cosine 2 alpha divided by 2. Let's go ahead and do the same thing for sine squared. As I'm deriving sine squared, I'm going to go back to my double angle formula, but this time I want to replace the cosine squared in terms of sine squared. So I'm going to start with cosine 2 alpha is equal to cosine squared alpha minus sine squared alpha. I'm going to replace cosine squared this time. So cosine 2 alpha is equal to, this is 1 minus sine squared minus another sine squared. So we get cosine 2 alpha is equal to 1 minus 2 sine squared alpha. And we're going to get a really similar result that we did for the cosines. I'm going to swap sides. So I'm going to write 1 minus 2 sine squared alpha on the left and cosine 2 alpha on the right. Let's go ahead and subtract a 1 from both sides. So I get negative 2 sine squared alpha is equal to negative 1 plus cosine 2 alpha. Last but not least, divide everybody by 2, which is a negative 2. So I'm just going to clean that up a bit, and I get sine squared alpha, negative 2's cancel, is equal to, I'm just going to distribute this negative up to my numerator so I don't have as many negative signs. 1 minus cosine 2 alpha divided by 2. There's our formula. Let's go ahead and put that up on the formula line. So 1 minus cosine 2 alpha divided by 2. If you take a look at these two formulas, there is only one difference. And that one difference is the sign. So I have a plus sign in my numerator for cosine squared and my minus sign in the numerator for sine squared. The power reduction identities, that's what these are. So the power reduction identities get me from a degree 2 on the left, and then the expression that we just derived is a degree 1. When it comes to calculus, it's much easier to work with degree 1 expressions as opposed to degree 2. Let's go ahead and continue doing some derivations. We want to find the cosine now of a half angle. And I'm actually going to use the cosine squared alpha formula. So let's grab our blue pen and start there. Cosine squared alpha is equal to 1 plus cosine 2 alpha divided by 2. I'm just going to do a quick replacement. I want a half angle instead. So I'm going to go ahead and let alpha be a half of an angle. So I'm going to let that be beta divided by 2. So I'm going to replace this alpha here and that alpha there. So working through, I get cosine squared, and I'm just doing the substitution because it's convenient, because I want a half angle formula. 1 plus cosine 2 alpha, but alpha now I'm writing as a half angle beta divided by 2, divided by 2. I need to take a square root on both sides. I'm just about there to my answer. The square root, since I'm in an equation, does give me a plus or minus, and we end up with cosine beta divided by 2 is equal to plus or minus square root of 1 plus cosine, these 2's cancel. So I get cosine beta divided by 2. And the plus or minus depends on where our angle lives. So that is, so depends on the quadrant. So beta 2's quadrant. So the plus or minus depends on that. I'm actually going to write this in black because I've got a lot of blue floating around here. So plus and minus, depending on the angle that beta divided by 2 lives in, square root of 1 plus cosine beta, all divided by 2. I can do the very same derivation for sine. Remember, the only difference between our sine squared power reduction formula and the cosine squared power reduction formula were the positives and negatives. So I actually don't need to go through and do all of that math. To get to the sine of a half angle, everything's identical except that sign. So square root 1 minus cosine beta divided by 2. And again, that plus or minus depends on the quadrant that beta divided by 2 lives in. Let's go ahead and work through some examples. So we want to be able to express these cosines and sines to higher degrees back down to a degree 1. So I want to apply our formulas from up above. So I know that cosine squared alpha is equal to 1 plus cosine 2 alpha divided by 2. Let's go ahead and work through that for part A. So alpha here is 6x. So cosine squared 6x is equal to 1 plus cosine 2 times 6x all divided by 2. This is equal to 1/2. Let's pull that out in front. 1 plus cosine of 12x. And I can distribute that 1/2. So I get my answer, which I'm going to go ahead and write in black here. So I get 1/2 times 1 plus 1/2 times cosine 12x. And we've got a cosine to the first degree. Next one is sine. So I want to go ahead and do a sine squared power reduction. Remember, the only difference in this formula is the negative up on top. So 1 minus cosine 2 alpha divided by 2. So just that negative is the change. So as I'm working through this one, sine squared of 3x is equal to 1 minus cosine 2 times my original angle, so 2 times 3x, all divided by 2. I'm going to put the 1/2 out in front. 1 minus cosine, there's that double angle, 6x. And I'll distribute that 1/2. Looks a lot like the last one. So I get 1/2 minus, I distribute that 1/2 to the cosine, 1/2 cosine 6x. The last one, now I'm going from a degree 4 to a degree 2. This is going to take a little more work. I am going to go ahead and use, though, this original formula up here for cosine of a power 2. But this one's to the power 4. I don't have a formula for power 4, but that's okay, because I can write something to the 4th power as something that's been squared twice. So I'm going to rewrite this as cosine squared 2x all squared. And we're going to work within, I'll even put square brackets here. We're going to work within the square brackets. So within the square brackets, I'm going to go ahead and apply my formula. My formula is 1 plus cosine twice that angle, so 2 times 2x, all divided by 2. So this is 1/2 1 plus cosine 4x squared. Square bracket goes there, square goes here. I've got to square that 1/2 and it becomes 1/4. And I have to square this 1 plus cosine 4x. So there's literally 2 of the 1 plus cosine 4x's. I'm going to FOIL this. So as I FOIL, first of all, I've got the 1/2. First is 1 times 1. Outer is a cosine 4x. Inner is another cosine 4x. So I've got 2 of those, plus 2 cosine 4x. And then last is a cosine squared 4x. I'm going to have to do the power reduction formula a second time right here. Let's go ahead and simplify this a little bit, though, to start. I'm going to distribute that 1/2 through before I do my power reduction formula again. Okay, so 1/2 times 1. 1/2 times the 2 cosine 4x. So this is just going to be plus cosine 4x. Oh, and actually this is a 1/4, isn't it? So hopefully you guys caught that. This is a 1/4. So that really should be a 1/4. So this should be a 1/4, which is going to make this right here a 2/4. Okay, so hopefully you caught that. Should be a 1/4. Luckily I caught it. So if I clean these up right here, 1/4 times 1 is 1/4, plus 1/4 times 2 is 1/2. And now 1/4 cosine squared 4x. I'm going to apply my power reduction formula right here. Everybody else is going to just carry along. So that's the 1/4 plus 1/2 cosine 4x. Those are both done. Plus 1/4. Do our power reduction formula. 1 plus cosine twice my angle now is 8x divided by 2. I can take that 1/2 out in front. So we get 1/4, I'm almost done, I promise, plus 1/2 cosine 4x, plus I have the 1/4. Now I'm working inside my square brackets, so that's going to be 1/2, 1 plus cosine 8x. So I end up with a 1/4. I get this plus 1/2 cosine 4x. Let's multiply these two and distribute them. I get a plus 1/8. And I get a plus, distribute it here, 1/8 cosine 8x. So the only thing I've got to combine is the 1/4 and the 1/8. I'm pretty good at fractions, but if you're not, that's okay. You can go ahead and just do this right in your calculator. 1/4 plus 1/8, and then just do a math convert to fraction, and you get your 3/8. So let's go ahead and put all of this up on our answer line in black. So I'm working with this now. So I did the 1/4 and the 1/8. I combined those. That's 3/8. And now the plus 1/2 cosine 4x, plus 1/2 cosine 4x, and then the 1/8 plus 1/8 cosine 8x. That was a lot of work, and there's a lot of room for error. I even made an error, right? So a lot of room for error. So say you're doing this on an exam and you want to make sure you've got it right. A really great way to do that is with Desmos, and I believe I've got Desmos open here. Do I not? I do have Desmos. There it is. So I want to go ahead and just bring Desmos over. Let me get rid of this so I've got a nice clean slate to work with. And I want to start by typing in that original function, y equals cosine to the 4th 2x. Now it gives me a warning, and if I click on that warning, it says only cosine to the 2nd power and cosine to the -1, which would be cosine inverse, are supported. Otherwise, use the stands for parentheses. So I need to change this and use parentheses. So parentheses there, parentheses here, all to the 4th power. Okay, that's the function that I'm looking to recreate. Let's go ahead and type in the function that we came up with, which is hopefully correct. Y is equal to 3/8 arrow over plus 1/2 cosine 4x plus 1/8 arrow over cosine parentheses 8x. Okay, let's take a look. Let's make this large. Okay, it certainly looks like one's on top of the other. If I get rid of the green one, which was my power reduction, I notice that it does draw right on top of the original function. So a really, really nice way to catch an error in case you didn't catch your error like I had just done. In the next video, we're going to go ahead and go through these applications of the half angle formula.